Hello, in this video I'm going to show you how to solve equations using a strategy called number bonds. Number bonds are something that you probably were introduced to in elementary school when you were considering different values that combine to add to make, for example, 10. And probably when you learned that, you would have done something like this. You would have had 10 at the top, and then shown that to get 10, you could add 1 and 9. You could also break that 10 up into 2 and 8, etc. There are a bunch of different combinations of values when you're adding two numbers together that would add to make 10. So this idea of taking a single value and breaking it up into two other values that would add to make that total is what's referred to as a number bond. I'm going to use cards here just to demonstrate that a little bit. So if you were looking for a sum of 5, you could think, okay, how could I make 5? Well, I could add 4 and 1. That would make 5. If I was being asked to find a sum of 7, I could add 6 and 1. That would be a fairly straightforward way of getting there. If you are more flexible in your thinking and you're able to use both positive and negative values, the potential combinations or potential number bonds that you have access to becomes infinite. So rather than only being limited to 1 plus 4 and 2 plus 3 as possibilities, as soon as I bring negative values into the situation, I now expand my possible combinations. I could do -2 and +7 to get that 5. Or in the case of trying to make a value of +7, if I'm not just limited to positive numbers like 1 plus 6, and 2 plus 5, 3 plus 4, if I'm allowed to use negative values as well, I've just added a whole bunch of other combinations to my possible place. So a possible number bond that adds to 7 would be +10 and -3. So keep that in mind as we're going through some of these equations. Right, so 7 could be broken up into 3 and 4, but it could also be broken up into 10 and -3. Okay, so the first equation that we're going to solve using a number bond looks like this. 5x minus 3 is equal to 2x plus 12. So in order to implement this strategy of number bonds, I'm going to look at the left-hand side and the right-hand side, and I'm going to break apart one of the terms so that it includes this 2. So in other words, instead of having 5x on the left, I'm going to break it up. I'm going to break it up into a 3x and a 2x. So these are equivalent. -3. I haven't done anything to the right-hand side yet. So at this point, I want you to consider that the left-hand side and the right-hand side of this equation are like two sides of a balanced scale. And I can see that I've got 2x on the left and 2x on the right. So the way that a balanced scale works is as long as I remove the same thing from both sides, it remains in balance. So by breaking that 5x into 2 pieces, I can remove 2x's from both sides of that equation. So now I've got 3x minus 3 on this side, and I've got just a 12 on the right-hand side. At this point, I can go to my card strategy, because I've got a value alone on one side. My variable is alone. There's only one of them there, so I'm going to be able to isolate that now. So my variable was multiplied by 3 and had 3 subtracted from it to generate a final value of 12. So to solve, I'm going to undo the subtraction and the multiplication in that reverse order. So I'm going to add 3 to the 12. So plus 3 on both sides results in 3x plus 15. And then I can get rid of that multiplier of 3 by dividing. And I have x equals 5 in the end. If you haven't seen this card system before, check out my other video where I show how to use those. Okay, we're going to solve another one using a number bond. So we're going to start 2x minus 3. Just put a line down here. 2x minus 3 equals 11x plus 24. Okay, so I can see that I've got 2x on the left-hand side, I've got 11x on the right-hand side. So I can use a number bond there. I can break that 11x up into 2 chunks. I'm going to leave the left-hand side alone for a moment. Break that 11 into 2 and 9 x's. So these are equivalent. I've got plus 24. I haven't done anything with that constant value yet. And now that my left-hand side of the equation and right side of the equation have 2 terms that are the same, identical, I can remove them both and maintain the equality or the balance of the scales. Get rid of those 2's. So I've got negative 3 on the left, and I've got 9x plus 24 on the right. I'm going to use another number bond here. Actually, I'm going to use my cards. I could do a number bond, but I'm going to use my cards. So I've got a value on its own, and on the other side of the equation I have just one variable, so I'm going to be able to use my cards at this point. So my unknown was multiplied by 9, and it had 24 added to it. That's my right-hand side. And the left-hand side is negative 3. So to isolate for that unknown, I'm going to have to subtract the 24. Negative 3 and negative 24 is negative 27. And I'm left with 9x on the right. That 9 is a coefficient or a multiplier. So to get rid of it, I will divide. I'll just change the color here. Divide by 9. That leaves me with x is negative 3. And depending on your teacher, you may be asked to rewrite it with the x on the left. But these are equivalent expressions. So. All right, let's do another one. One more. So 5x plus 10 equals negative 2x plus 38. Okay, so this time I'm going to use a number bond again, but I have to take into consideration that this 2 is a negative. So I have a couple of possibilities. I can play around with different combinations that add up to 5, but that have a negative 2 in them. Or I can play around with combinations that add up to negative 2 and have a 5 in them. I think I'm going to do (7x minus 2x). So I've changed this 5 into a 7 minus 2. I'm leaving the right-hand side on as it is. And the result is now I've got negative 2x, or minus 2x, and I have the same term on the right-hand side, so I will be able to eliminate those. Eliminate those two negative 2x's. That leaves me with 7x plus 10 on the left and 38 on the right. So my unknown was multiplied by 7, and it had 10 added to it, and the resulting value is 38. So we'll undo those things one at a time. Undo the addition of 10 by subtracting 10, using the 7x equals 28. That 7 is a multiplier. Divide to get rid of it. And the result is x equals 4. You can show that division eliminating the 7's by canceling or crossing them out. And that's how you use number bonds to solve multi-step equations.